and then respond. Thanks.
Yes, sir, they're very clear.
All right, thank you. Okay, now I'm sharing the screen. So I'm sure right now you can see the screen, eh? Can you see the screen?
Can Doctor.
Can, eh? All right, thank you. Okay, for those, it's already 8, so we are going to start. Okay, Assalamualaikum and very good morning. For this morning, for this week will be the first week of the semester. So hopefully everyone is ready for the semester. Okay, so have you all eaten? Have you guys eaten or taken any Milo or coffee or anything? Bread? Guys, have you eaten?
Yes,
Can you just put
already.
that in the
Yes.
chat if, yes, eaten already, okay? Just put that in the chat if you're eaten, or if you don't have mic, then just write that in the chat. Okay, so hopefully everybody have taken their breakfast. Okay, and is Genki lah. Genki ni means that so right now I'm sharing you the screen. Okay, the screen of the ULearn. So this is what you should be looking at if you enter ULearn. Okay, if you are in front of your PC, then just let's go into ULearn because I'm going to explain what you need to do weekly. Okay, during class, I will give you instruction according to week. Okay, so you can just go through where there is general information. Okay, you just click there, you get all the general information. This is where I actually post to join the group, Telegram group, and so on. Okay, just as hypnosis. So you can see that there's like a lot of sine wave over there. Okay, and then you can just look at who I am. So if you haven't know me before, so you can sorry, tablet went out of battery. So if you I have never teach you before, so you just go to the information, right? So under teaching plan, later on I will upload that teaching plan. I didn't get to upload yet since actually on Monday and Tuesday, I went to KL for outstation. I gave a talk, one day talk in Cyberjaya. So I just came back on Wednesday. So that's why, one of the reasons why Wednesday class I postponed, because at that time I didn't have any voice. Okay, one day talk in a large hall. Okay, so now we go to week 1. Okay, week 1. So basically what you will see every week is something like this. Okay, week 1, if I give you specific instruction, just go through the instruction. So I will normally post it one day before, and if you see here is that I will actually add in what are the lesson learning outcome for this week. Okay, means that this week what I expect you to actually achieve, or you expect to have learned by the end of this week. Okay, so for example, for this week is that student are able to explain the concept of continuous and discrete time signal, able to apply the basic operation of signal for times transformation. All right. So, and lesson 1.1, okay, I need everybody to do this. Okay, manual attendance means that you are going to be the one who are going to click your own attendance, not me. So just then for the attendance, that I'm going to take it in during the class hour. Class hour is 8 to 10. Okay, so meaning that even though the class is a synchronous class, then you must also join the ULearn during the class time and go to the attendance. So just click that. Okay, and then when you click there, you will see that for example, I already opened this. Okay, yesterday it's okay, just ignore that. You have the today class, which is 18 March. So just click on submit attendance. Okay, and just click on present. Okay, so save. That should be done. Okay, so very easy. I mean very straightforward lah. Straightforward. Okay, and Lesson 2 is what I have, lesson 1.2 is what I explained yesterday, which is for the online class. Is today we are going to go through the synchronous class using Webex. So these are the descriptions. So every week I'm going to use the same meeting number. So but anyway, I will post this to the weekly tab. And we have class activities. So during class, we will have few activities. So this one is by instruction, or if I'm going to give you a synchronous class, then the instruction will be given in this lesson 1.3. 1.3 means that one is the week lah. Okay, means that for next week is lesson 2.1, 2.2, and so on. And lastly, towards the end of the class, normally I will ask for a student to fill in a feedback form. This feedback form normally have 5 to 6 questions. Very simple question. This is considered as attendance. Means that the compulsory things to do. So if student didn't submit this feedback form, then consider that so the attendance is less than 80%, then you might be blocked from the final exam. So this is a soft reminder to all. Please make sure that to actually do the attendance, initial attendance, because I know and you all know during online class is what happened is what happened normally online class. Right now I'm opening I switch on my webcam, right? But I'm not sure if the student just switch on the Webex and then goes to sleep. All right. So in order for you to actually understood about the class, so you're going to actually submit the reflection class by today noon. Means that you only have like 2 hours. You can do it immediately. After class, I will normally ask student, okay, fill in the feedback form and click on that and answer the feedback form. Okay, normally feedback form, if you answer out of topic, means that not related to class, I know that student didn't attend the class. Okay, so everybody understood? Okay, this is normally what I will do weekly because we have online. Of course, if I have the face-to-face class, normally it will be different method. Similarly, I will take attendance and so on, and by the end of the class, you're going to do reflection also using ULearn. Okay, okay, understood? Any question? Guys, dengar kan? Dengar ke tak ni? Am I talking alone? Testing. You can, hello?
Understood, is it?
Understood, class. It's clear.
Okay. Thank you. Okay, no problem. Okay, sorry. Because I need to keep on reminding myself that I'm talking to a camera right now. So sometimes when I talk blah, 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 and suddenly student after 1 minute, 2 minutes say, Doctor, we cannot hear anything. Okay, so it means that the setting of my speaker or microphone is wrong lah. Okay, so that's why I will keep on asking you, are you there and so on. Alright, so let's look at the slide. This slide I have not uploaded to ULearn yet, but anyway, I will upload it later after finishing class. So this one is a very simple instruction for this class, and so that I hope that all students will follow the instruction. Means that towards week 14. So let's do the first activity. Okay, take out your handphone if you're using handphone, or if you're not using handphone, then I'm going to post this link to the chat. Okay, so click and note that link, fill in your form. Okay, so if you click on that link, right, the link is in the chat. So click on that link. This is, I need to know my students. Since I couldn't see your face, so at least I want to know who you are. So can you just fill in this quick form? Okay, fill in your email address, your full name, matrix ID. Okay, choose your course. Example, some of you guys are BEKG students, so just click on it. Okay, and if you are normal or direct entry student, direct entry means that the one who are from diploma, direct entry from other than UTEM or from Polytechnic, so you choose on direct entry or normal intake. And then what's your CGPA last semester? Hopefully everyone know what are their CGPA. should be, because you should know what subject you fail or what subject you excel, And then have you taken BEKC 2433? Means that okay, those who just came in, go to the chat and click on the link, okay, and just click there. Yes, I'm repeating. If you're not repeating, no, this is my first time. And if the above is yes, so please state your grade. Means that if you're repeating, it might be C- and below. So just click there so that this one is where I'm going to monitor the student. So that if you fail last semester, hopefully this semester you're not going to fail. Okay. And this is your frequent use email. This is normally I will use this for official communication with student. If the faculty give some official information through email, I will directly forward their email. Because sometimes there are lots of documents and so on, instructions. So it's preferable that it's being sent by email. At least you know how to use email since from means that you not is that you practice how to use email officially, okay? Because sometimes students do not know how to use email. They write email as if they send a message in WhatsApp, okay? Just attach some documentation without any introduction, okay? So you can see example of my email later on when I send to you some document, and that is how you should write an email, official email. And your phone number. Okay, so let's do that. I give you roughly about 1 minute to do that. Okay, let's see who fill in the form. Oh, not this one. It's the form. The information. Sorry. Sorry. Wrong. Okay, this one. Right. So let's see. Okay, 15 students already responded. Okay, good. Very good. Who is responded? Okay, these are the students responded. So okay, let's go. The other student. We have 40 students in this WebEx right now. So fill in the link, okay, that I gave in the chat. Fill in that. Okay, we have 17 respond. Okay, I'll give you 1 more minute to do that. We wait until more than 30 fill in the form so that we give time. Some of you guys enter late, so make sure next class, for my class, need to enter sharp at 8 because we have only 2 hours class. If we start late, 8:30, then it was going to waste time and we cannot finish the syllabus. Okay, fill in the form. I will keep on giving the link to the chat since there are a few students just joining in. Okay, I see some familiar names inside here. Some of you guys I have taught last semester for subject Introduction to Mechatronics. Okay, so for those who have taken that subject with me, so you know how I deliver class by giving instruction, and then we have some activity, and then we have feedback. We have 24, okay, 6 more, then we will do another activity. Okay, this is like a icebreaking. If you have any question, you can just ask me. Don't be shy. Okay, we have 31 students. Okay, congratulations to all. So you have done a good job. Okay, so let's now go to the next activity. So I hope that by now, those who have joined the class, just now we just, again, just give you the link to fill in your information. And then what you need to do every day between class hour 8 to 10 is to manually tick your attendance. This one you can just go to ULearn and on the week. So this is under week 1. So click on attendance and submit your attendance. Okay, click on present. Okay, and we have class activity. So for today is that class activity is going to use Padlet. So let's go to Padlet. If you are in ULearn, just click here. Okay, so hopefully everybody please go to ULearn right now. Okay, at least you need to test that your ULearn is working. Okay, go to ULearn and test out your ULearn. I'm going to look at how many students join the class. Participant. That's 72. Okay, and for your information, I actually have another instruction that student need to do. If you look in week 1 is that you need to join the group. Okay, according to section that you have registered in SMP. So I presume that those who are joining this morning class is plan to take the signal system, BEKC2433 under my section. I presume that. If not, I'm not sure why you join my class. So please, if you have not done it yet, okay, go to the join according to your group section. Click on which section that you register in the SMP. Means that you plan. Means that if you haven't changed it to section 1, then just click on choice section 1 and later on with your academic advisor, change it registration to section 1. For example, if you are registered section 2, change it to section 1. Okay, and those for BEKG student, actually BEKG student, we open two slots. You can either join my class or Dr. Faik class, section 2, or Dr. Nurul Ain, which is we open specially for BEKG student because last semester, apparently 30 students failed the subject. Okay, 30 students failed BEKC 2433. So the faculty open one section special for the BEKG student, but you can actually join either any of the classes, section 1 BEKM, section 2 BEKM, or BEKG, depending on your class schedule. Okay, so click on that if you haven't did that. Okay, so right now we were doing the class activity. So have you joined the Padlet? Join the Padlet there. Once you join the Padlet, what you actually see is that we have the first one. Let me know you. You know me, you can see my face, okay? But I cannot see you, and I do not actually know a lot of you. I think 90% I have never met the student before, except for my academic advisor student. So, can you just simply click on this plus button? When you click on that plus button, it will come up with a title. So, on the title, put your full name, okay? And your hometown. For example, I just post just now my name and then my hometown is Cheras. And then don't forget, because I want to know you guys, so click on the camera. Take a selfie. If you're using your handphone, you can do the same thing. You can download Padlet apps and you can do that. Okay, so just post like what I did. Example here. Okay, post your selfie. So Muhammad Izzat already start that. So I'll give you 1 minute to do that. Very fast one. Izzat, if you want to edit, just click on this. You see that there's a edit button, the pencil button. Click on that, and then you can just upload your face or upload any photo. You can either upload photo or you can take a selfie using the camera apps. Okay, let's do that. 1 minute. Mana yang? Where's your photo Izzat? Izzat? Aminuddin? Oh, Aminuddin orang Durun Tunggal Okay, dekat je lah. The rest Chong Jia Kuan. Okay, ada Tan Zihu, Pahang. Oh, Jeffrey Perak. Lee Ji Yajin, very happy. Looks excited I hope this is this morning photo Okay, looks very excited. Okay. Wong from Klang. Cham also from Klang. Okay, Tang from Sarawak. Okay, Aiman, Iman. Alright. Keep it on, keep going. Upload your detail, put your name, where you are from, and then post your selfie. Okay, selfie or your any picture lah related to you Not don't post your cat face Okay. Your own face. I would like to know you guys. Okay. Tan Zihui, Chong Jia Kuan, Minuddin. Izzat tak upload lagi gambar dia. Oh. Oi. Okay, 1 minute. 8:23 I give you 1 more minute. Ini Melan, Im King Hong. Okay. Good. Nice to meet you. Who? Justin Oh, name you have Justin there because this one is reflective So Justin. Risha. Wow, is that a photo edit? Risha? Looks like something on your shoulder.
Using apps ke apa?
Oh, using apps. Okay. Alright. Khairunisa. Oh, from Sabah. Okay, hi. Is this your house? Shakirin. Falmisha. Okay, boleh juga. If you want to add on your short name pun, yeah, you can put there. Tan, this is UTEM photo in matrix card looks serious. Okay, so I hope that everybody get the idea Okay, so you have did that. Okay, this QR code is to fill in the form just now. So let's just go to the briefing, very fast one. So we have our class twice a week. So each class is 2 hours. So Wednesday 8 to 10 and Thursday 8 to 10. So my class, we will start at 8 because if we start late 8:30, that means that we only have 1.5 hour. And for subject senior system, quite a lot of topic to be, not lot of topic, we have only 5 topic, but inside the topic, because most of the chapters are all calculation. So I need to take the time to actually explain to you and make you, once you understood, then we only move to the next chapter. That is how I do for this signal system. And I have, alright, so a little bit about myself for those who have not known me before. So I have been, I'm actually right now admin post at the deputy director Timbalan Pengarah at the Center of Academic Excellence Scholar, which is we are giving training to academic staff on delivering teaching and learning and on research and so on. So I'm at that position, deputy dean academic, deputy director. So I have been, and it was from April 2019, and just recently, since February, actually the term was extended until March 2024. So a long way to go, 3 more years. And I am from the mechatronics department. I have been with the department in FKE since 2005. So it has actually been 16 years with FKE. Okay. So if you do come back to UTEM, I'm not sure if some of you guys are here back in UTEM. So my room number is at A2-6. So if you're taking the lift, just click on or just climb the stairs to level 3. Okay. And this is my official email, just in case that you want to contact me officially, then directly through email. I would prefer that anything regarding academic, please email me so that we have black and white. Okay, if in Telegram, it's very hard for me to actually refer back. So that is the email. And for my office number is this office number, and this office number is actually when you call direct to my handphone number. So don't worry about thinking that I won't pick up the phone. I will pick up the phone because it's directly to my handphone. Okay, so just call this office number. And this is some of my qualifications. So I actually did my degree in UTM Skudai, and discipline is on power electrical engineering. So I'm actually pure electrical engineering. Then continue master by top course, which is in UTM Skudai directly. Then I went 2005 here. Okay, 2005 I enter UTM, and after 2 years teaching, I went for my PhD. So if you see here, I actually have double master lah. One master is from Tokyo Institute of Technology, is master by research, and also I have the PhD or Doctor of Engineering from Tokyo Institute of Technology, Japan. So from the same university. I was in Japan 5 years doing my PhD. Right, and my discipline is on precision engineering. It's a sub field under control engineering. Okay, so anything, if you want to know detail about me, you can just go to my website. Very simple website link, mariamghazali.com. So some of the rules and regulation about this class is that I hope that all of the students can be on time. Okay, do not and I will start on time. Basically, I won't wait for the other student come in. So if you are late, then sorry about that. So make sure that next class come early. Ask question for your own benefit. So if you do not understand some parts of that I'm teaching, because we are online like this, I cannot see your face. If in face-to-face class, I know when I'm teaching, I can look at student face if they understood the explanation. Now, I do not know if you understood it. So please, you can just stop me, ask question. I think you can just click on raise your hand somewhere in that WebEx there. You can click on there, raise your hand and so on, or you can unmute your mic. Sometimes I won't notice that there's someone asking question in the chat. So I prefer that you unmute your mic. Okay, there will be class quiz in the last of 50 minutes of class. Well, this depends on the attendance. If it's too low attendance, then I would do a very quick quiz. Following code of conduct means that attendance must be 80%, more than 80%. Okay, less than that, you will be barred from final exam. So this is related to what I informed just now in the ULearn, that the feedback form and attendance need to be done during the class hour. Okay, just go to ULearn. Okay, so consultation is based on appointment through email or availability. So no SMSing my private number. If you actually have my handphone number, so do not send that. Do not send anything through my handphone number. Okay, except for Telegram, it's okay because you join the Telegram using a link, kan? So you can just if it's is something that you want to ask about, for example, my PA student, so they can just PM me, private message me in the Telegram, okay, privately. So it's okay. But other than that, no. Okay. Lecture notes will be uploaded to ULearn, so you can download from there. Normally, I will upload before class, but just for today, I didn't get to finish upload it yet. And another tips, how to score for this subject, because this subject is high chances that lots of students fail, because it's a tough subject. Okay, so do pre-read and post-read the main textbook. I will share the link later on, and class note to score the subject. So it means that after class, do revise again so that everything you remember, you understood, and then next week before class go through the notes again. Okay, so that they will actually enhance your understanding. And of course, lastly is that plagiarism and cheating are not allowed during quiz, assignment, exam, okay, final exam. So make sure that final exam right now, if you're caught, directly 0. Okay, so any information ni, this is last time we have class representative, but right now we have the Telegram group, so I will directly use the Telegram group. So we have 5 topics actually to be covered under this Synchronous system. We have the first chapter, Introduction to Synchronous system. Roughly, we will take about 3 weeks. And then chapter 2 will be on Linear Time Invariant System, about 2 weeks. Then we go to Fourier Series, about 3 weeks. And chapter 4 is Fourier Transform, about roughly 3 weeks. 4 weeks, and last chapter will be the Z transform, roughly about 2 weeks. Okay, so each of this topic later on I will upload the teaching plan. You can go through. I'm not going to explain right now. Okay, and upon the completion of this subject, students should be able to achieve 3 LOs. Which is LO, learning outcome 1, will be to apply the basic knowledge of signal system for continuous and discrete time signal. Okay, which is map to PO1. PO1 is ability to apply knowledge of mathematics, etc. Blah, blah, blah. You can read that. Okay. LO2 is analyze the linear time invariant system in time domain and frequency domain. So basically, LO2 is reflecting to chapter 2 and chapter 2, 3, and 4. And LO3 will be analyze the other system using traction form. So this one will reflect to chapter 5. So all of these are actually covering all of the chapters. Okay, you can just go through this one later on. I will share you the slide. Okay, some reference that you may want to refer to. Okay, if you are in UTEM, you might want you can go to the library and borrow the books. Okay, I'm using this few combination of books. Okay, 1 to 6, and 1 to 5. And actually, I refer a lot of book for Synchronous system. I think more than 10. Okay, so don't expect that the question for midterm and final exam will come up from one book. And because of we have the COVID, due to the pandemic, then our exam, the question is open book style. Means that student can refer to any books, to the notes, even to the video lecture and so on, right? So means that the question will be a higher order thinking skill. So during this class, I'm going to give you lots of examples of higher order thinking skill question, so that you are familiar with the style of question. Okay, it's not going to be direct question, but at least you know, oh, okay, you need to do a reverse engineering on the method just now and so on. Okay, class instruction all through Yulen. This one will be the assessment being done. So we have 3 quizzes. Okay, 3 quizzes, which is comprised of 5%. Group assignment. Sorry, this we don't have group assignment because it's COVID. Because COVID, right? So we don't have group assignment. Okay, because group means that you need to discuss in group, face to face normally. But if we do give you group assignment, then one group maybe 3 students and one might be a sleeping partner. So all of the assignment for this subject will be individual assignment. And most for assignment 1, it will cover will cover chapter 3 and will be using MATLAB. Okay, so hopefully all students already have MATLAB on their computer. If you have not, if you don't have MATLAB, then please install it. And for the midterm exam, we have roughly in week 9, okay, covering 2 chapters, chapter 1 and 2, and it will be 20%. And we have final exam 60% covering all chapters. And just a reminder, late assignment will not be accepted, and basically 0 marks. That's all. So make sure that once you got received the assignment, please make sure do not do it last minute. And do not copy from your friends. If any of the solution is similar to 3 students or 4 students or even 2 students, both students get 0, right? So this is a reminder. Okay, this one just skip it. So this is something that just a motivation this morning. Okay, so if you want to be success, you want to get good grades for this subject, even for other subjects. So this is something like, oh, you get a very good CGPA. Okay, but the thing is that you don't people do not see what you actually do. Okay, you have the persistence, means that you keep on weekly, do some tutorials other than what the lecturer gave you. You find out some explanation in the internet using YouTube or even from the Google. Okay, so additional things that you do actually will give to this success rate. Failure, sometimes you fail. Okay, sacrifice of sleep basically, or sacrifice online gaming. I'm not sure all the boys in this class because nowadays I think people are crazy about online gaming so hopefully gaming is gaming, but your study is, please focus on it because in the end you need to have one certificate so that you can sell yourself using that certificate certificate of Bachelor of Mechatronic Engineering degree. Good habits, waking up early, okay, sleeping early. Okay, by 10:30 p.m. you already go to sleep and you can wake up early in the morning by 5:30 a.m. Okay, so that's a good habit that might give you a good routine. So dedication and hard work. So this is some things that take into consideration. Okay, so I hope that by now all of you know how to calculate your GPA or CGPA. If you don't know, then please refer you to your academic advisor. And what you plan looks like this. Okay, I plan for this semester, I plan to get a CGPA 3.5 or GPA 3.5. You think it's a straight line, straight road, but actually you have lots of things. Okay, you have quizzes, assignment, midterm, again feedback that I give to student, a very short feedback, midterm exam, presentation, project. So what happened here? So this is where you need to put all your effort for to commit to the subject. Okay, this is some things that I think just skip that. Okay, so this is what people see in engineering. If you are not tired, you are not doing right. This is true. If you're taking mechatronic engineering and you don't feel tired, then you're not doing something correct lah. Unless you are a very brilliant person. Okay, like I take an example of my sibling, my brother. Okay, my little brother lah, but not little anymore. He's already 33, working already. So 33, during his high school time, he never did study. Okay, he went to the Sekolah Alam Shah. Sekolah Alam Shah, you know Alam Shah, the boys' school. So Alam Shah is a top boys' school lah. So during weekend, he always come back home, but he didn't study. He just play the computer game. We don't have the gaming that time. Okay, computer game and then sleep. And then when we ask, oh, tomorrow I have an exam. Okay, but apparently, even though he didn't study, he was the best student for his batch. Okay, but I'm not like that. I'm the one that need to work hard to get a good grade. So you know who you are. Okay, do not follow your friend who actually sleep but get a very good CGPA. Okay, so this is what happened to me during my PhD time. When I sleep, I dream about all the equation, or even I dream about doing my experiment during my PhD. So this is how or what you should be doing. If you never dream about your subject, then you might not be focusing much on that subject lah, that course. All right. So that's all for the introduction. Any question? Any question? Okay, the rest already done. Okay, ni. Any question? No? If no question.
No.
No question, Okay, thank you. Okay, no question. Okay, so we start with chapter 1. We directly start class, Okay, so for class, every time for class signal system, make sure that you have a piece of paper in front of you. Piece of paper, and you have a pen or pencil. Okay. Why? This is how I do it when face-to-face class. If you don't have a piece of paper and pencil or pen, then you cannot follow what I'm going to teach for Synchronous system. Okay, Synchronous system is like subject maths. Okay, maths engineering, where I'm going to explain about method, how to calculate and so on. So if you just watch what I explain, then you will never learn. Okay, to actually learn something is that you need to adopt it, you need to practice it. Means that the first practice is during class hour, means that you follow what I'm teaching. Okay, so I explain about this, then later on you follow it. Okay, so these are the tips, okay, to score A. Okay, don't expect that, oh, okay, I will do it later. I will do it later lah because I don't have time to do it now. Okay, so yeah, so I don't have time to do it now. You might say that, but you know, every week you have a lot of subject, right? So when you have a lot of subject, when do you think you are going to revise it again? Next week before class? I didn't think so. So when you have class, during that time, please directly do take note, okay, during class. So this one I'm giving you tips how to actually excel. For the case like myself lah, okay, I'm not that brilliant, but I do work hard. So we go to first chapter, which is Synchronous system, introduction to Synchronous system. Okay, and under this chapter 1 is that we have a few topics. So that for today is that I'm going to cover the introduction part, and then the continuous time and discrete time signal, and then we are going to go a bit on transformation of the independent variable. Okay, so hopefully by today I'm going to cover these 3 main topics, and for next week is that I'm going to cover for exponential and sinusoidal signal, the input, impulse and unit step input, continuous time and discrete time system for the whole system, and basic system property. So if you see here is that what is the difference between signal and system, because that is the topic, right? The subject is signal and system. So what is it? And you have learned what is learned in last semester class, introduction to mechatronics for the mechatronics student. So you have an idea what is system. Okay. So let's just look into the first slide. So for the introduction is that what you're going to learn in Synchronous system is that to represent a signal using equation or mathematical technique. So you see that lots of signal like this. Okay, you have the continuous, this is a continuous time signal, this is discrete time signal. So you are going to represent it in terms of an equation. So this is where you're going to describe and analyze the system which process signal. Okay, remember, or if you just take an example of, let's say, take a system, cruise control as a car. So you want to control the speed of the car. So what are the signal that is going to make the car speed up or slow down? So you have a signal. You give a signal or input to the system. So signals are variable that carry information. So example, you are talking about voice recorder. So voice recorder is something when you talk, okay, you will give some, there's a vibration, vibration. So this vibration, if you have a sensor, it will capture it in terms of signal, sinusoidal signal, combination of sinusoidal signal. So this signal can be represented into an equation. So how to do that is that we are going to learn in Synchronous system. So the system is something that going to process the input signal to produce output signal. So if you look at this block diagram over here, you have the system, okay? Then you have the input signal, okay? And then you have the output signal. Okay? So the input signal normally of course in this subject signal system, we have the continuous time signal. Signal normally is represented by continuous time signal. And we have the discrete time signal. So what does it mean? Okay, what does it mean? Okay, So it means that we take a signal, for example, this is a signal that you see that is continuous. So it means that if the signal is connected to each other, it's a continuous time signal. It means that there's no sampling done to that signal. This example of what you do when you when you make a circuit, then you are going to tap the signal out using a voltmeter, or you tap it out using oscilloscope. So you see that in the oscilloscope is that there's a waveform, and it come out something like this, okay, a continuous time signal. Okay, so this is continuous time signal, and the graph below is the discrete time signal. So discrete time signal is representative of the continuous time signal, but it's being sampled. Okay, sample in the case of this is being sampled by integer 1. Okay, so sampling time. We determine the sampling time. So let's look at an example of in mechatronic system. I take an example of control system engineering. Okay, we want to do, we are going to control a real-time system. So it means that we control the hardware. Okay, and normally we don't put a sampling time 1 second. Okay, for the sampling. So sampling 1 second, it's too low. Normally we put the sampling time means that 1 millisecond. Or 0.1 millisecond. Means that this signal is being sampled lots between 0.1 milliseconds. Okay, if you see compared to this one, it's only 1 second. So when you do the sampling like this, okay, time sampling, you get lots of data. Okay, you can actually represent this continuous time signal more detail. But if you take out this signal, it wouldn't actually represent back the continuous time signal. Some data might be missing during the process of filtering or translate it. Okay, and when you have a system here, okay, whatever the system is, if you have a electrical circuit, so you can get what the input signal is a voltage. Okay, the output might be let's say speed, okay, to control the speed. Okay, so in meter per second. Okay, so this is where you want to look at what are the speed. So overall, what you are going to learn is about the system, and you have the input and output. So we have, in summary, we have the continuous time signal and we have the discrete time signal. And these two, in this topic, chapter 1, we are going to cover both continuous time signal and discrete time signal. So let's see what are the example of system. So example of system that I give here is a circuit. Okay, let's say we have a circuit. Okay, we have circuit here. We have a resistor. We have the capacitor. Okay, this is grounded. Okay, and then we have resistors, and we have here output, V out, and then we have the input. Okay, so if you take the input, this is a system. System here is represented by the circuit. So let's say that the input to this, let's say the input to the system is a sine wave. Okay, sine wave. So you have the system over here. The whole thing is a system. So what is the output? Okay, does the output give you the reverse of the origin signal? So this is what the system will define how the output, what the output signal will be. Okay, so input, this is example of continuous time signal. Okay, we take it the example of circuit. So this is continuous time signal, and we have the output is also a continuous time signal. Okay, let's say change the color. Okay, let's say if we are taking the discrete time. So similarly, remember, discrete time is by sampling. Okay, sampling of 1 second. Contoh example, it can be sampling by 0.1 millisecond. Okay, it can be sampling by 1 millisecond. So it depends on you. Okay, you are as an engineer. So which one is better? Is it sampling by 1 second? Is it sampling by 0.1 millisecond? Is it sampling by 1 millisecond? Okay. So sampling time is important to determine the correct output. Or in control, you want to control the positioning or to reduce the error. So for in control, the smaller the sampling time is better. So we do opt for the 0.1 millisecond. Okay, the smaller is the better because you can control the output with precision. And when we talk about precision engineering, is you control it. Error is about nanometer displacement only, error very small. So that time, last time when I did my PhD, is even my student right now doing master and PhD, they are focusing on precision engineering, control a system for precision. So the positioning is less than nanometer, okay, less than 1 or 3 nanometer, right? So when we want to do this discrete time is that we need to do sampling. So for the case of this, okay, let's say that I'm sampling it 1 lah, because it's too small to do this. So this is 10 example. Okay, this is 20. Okay, so if I'm sampling it by 1, then meaning that I have the signal like this. Okay, the signal will be represent something like this. Every 1 interval, you are going to have a sampling. So if I draw this out in the discrete time, okay, meaning that I have here 5 and 10. So I have something like this, something that look like this. Okay, so this is the representative of this signal. For example, this is xt. So when we represent the signal in discrete time, we are going to write it as nxn, square bracket. So for the continuous time signal, is going to be represented in xt. Okay. And for the discrete time, it's going to be represented in a square bracket, xn. Okay. So this one will be t over here, and this one will be n. Right? And another example of system will be automobile, camera, robot alarm. So I'm going to give you one example, which is circuit only. Okay. So that's the idea. Okay. So what are the objective is to characterize the system in detail to understand how it responds to various inputs. So a system is something that is like this just now. Okay. This system, when you give an input, what is the output? So the objective is to characterize the system. Okay. Sometimes, okay, when you're in control, you want to model the hardware. Yeah, hardware. Okay. And I think you have learned control 1, Have you learned control 1, the modeling of a system, modeling of electrical system, modeling of mechanical system? The mass spring damper. Guys, have you learned that in last semester?
I'm not yet.
Yeah, not yet. Okay, who else? The other student? Other student? Have you learned modeling yet for the control 1? Guys? Mana begini? Dengar, hello, are you there? Sleeping. Everybody is sleeping. Not yet. Oh, okay, not yet. So when are you going to take control 1?
Now, doctor, now we are taking control 1.
Oh, okay. Now you're taking control 1. Okay, so that one should be okay. It means that in parallel. So so when in control 1 later on, you will learn that any system can be modeled. Okay, model using mathematical equation. For example, the damping of the car, quarter car system, a car. So you have take on the quarter. So we have the damping, the mass damper, and the spring system. So you are going to do that modeling. So you get the system modeling over here. So after you get the system modeling, we take it out and we make it into a transfer function. Okay. So this transfer function, normally, when you are doing in control subject, you can either run a controller, design a controller using hardware directly, give an input to the hardware, and you will actually monitor the output or collect the data and do a controller. Okay, that is one way. Or you start with a modeling of a system. Okay, So you have the system and you know how to model it. So after that, you will get a transfer function. And based on that, you're going to use MATLAB in the Simulink to actually model it, do an equation in the Simulink. And you can just give simple signal input and look at the output. So this is what signal system is about. So in this subject, mostly you are going to look at this input, okay, on the signal itself. And of course, in the system is mostly example of system that you are going to apply. Okay, later system is more on the control engineering subject. Okay, and second one is that to analyze the existing system. So either you need to estimate the output parameter. If you know the system, so you can estimate it. And third one is that designing system to process signal, so in a particular way. For example, you want to enhance or restore signal that is degraded due to high noise. Okay, so remember in introduction to mechatronics last time, you learn about how to filter noises, okay, using filtering. So this is one way. In signal system, you have the signal. So how do you actually filter the noise or enhance the signal? Okay, sometimes not sometimes lah. Example we have for example a photo, very old photo during my time, my baby time. My mother took a photo of me, so it was the photo was quite blurry. Okay, so the aim of you can use the Fourier transform or Fourier series to actually enhance the photo. So these are the techniques to actually enhance something, enhance the signal. So example of a system is aircraft respond to both pilot and command wind, electrodiagram, so electrocardiogram. So I don't know if you guys are familiar, but I have migraine, very bad migraine last time. Right now, I do keep the migraine under par. So migraine, when I have the very bad migraine last time, I actually went to the doctor to actually check for the EEG. Okay, EEG means that they will put wires on my head, and then about 30 minutes, they will collect the reading of all the signal from my brain lah, I think. I will say from my brain. So from that signal, they will interpret, okay, what is my diagnosis. Okay, so these are the way of an example of a system. Okay, to tap the signal, how you do that? You have the sensor. So that sensor will tap the signal, then that signal will be the input. So if you're talking about a controller, then if I was a robot, example, if I was a robot, then might be the doctor will give suggestion how to actually reduce my migraine, give a feedback, something. So when they give a feedback to the system, then my actually I can reduce my migraine. So that is the way the system work. So we have a system and then input. Normally we tap it using a sensor. So whatever you learn in Introduction to Mechatronics last semester, please remember it. Don't totally forget it. Don't totally delete it from your RAM. Okay, don't delete that. Keep it. Okay, all the notes, keep it. And because it's useful later on for this subject or even for next coming when you're doing IDP project or even your final year project. Okay. Okay, this one is example of electrostatic of a system. This one last time I did it during my PhD. So electrostatic system, what actually it derived using a signal. Okay, so what's the input and output? So the input to the electrostatic actuator is a voltage. Okay, in compared to electromagnetic actuator, or we call it as motor, the input is actually current. Okay, current. When you have current, then you have the motion. Remember last time I think I taught you guys. So you have the right hand rule. Okay, you have the current going up, so you have the motion in clockwise position. So this is electromagnetic actuator. But for electrostatic actuator, it depends on the input is voltage. Okay, so this is just some theory how to derive it. Okay, and this derivation of theory is actually based on this actuator fundamental. So if you see here, the fundamental of electrostatic actuator is based on overlapping area when you give a signal. So let's say that if you see here stator A is the first upper stator connected to the lower stator over here, okay, which is connected to voltage V1. Okay, and we have one more stator, stator B, which is connected to V2, which is the center stator or electron. And if you see here is that this stator A, B, A here up and down, and the center electron is fixed to the base by a screw. Okay, so it's fixed. And the electrostatic actuator is based on the capacity of overlapping area. When you give a voltage, then it will move depending on the difference between the voltages. Okay, the voltage that you give here with the grounded version. So the mover here is these two electrodes connected here, and it's going to be grounded. So what happens that let's say that I apply voltage V1, this one. Okay. Apply it more than 0 means that for this case is that I apply it 2 kilovolt. Okay, 2 kilovolt. What happens that there will be attractive force between this stator A and B. So the black line is actually this empty space. The electrode beam is the one that is gold. So you can see that it's not overlapping. It's not aligned. Okay, it's not aligned. What's my pen? It's not aligned. So you see here. It's not aligned. Okay, so it's not aligned. So when you see that it's not aligned, this is where you can actually move the actuator. So actuator is what? If you remember, actuator is something that when you give input, you will give an output, a movement. Okay, it's either movement in linear actuator or linear motion or rotary motion. So the case of this actuator that I designed is that it's going to give motion in linear. So when I give this V1 a voltage 2 kilovolt, then the mover here, because this stator is fixed, this mover, okay, we see that this mover is actually moving. It's not fixed to anything, right? So because of that, the mover will shift to the left. So when it shifts to the left, you can see that it's already aligned. And when it aligns, it will stop. Okay, so that's the concept of electrostatic actuator. Okay, so let's say that, okay, this right now, just now the mover was moving to the left. Okay, I want it to move reciprocating motion. Reciprocating motion is that moving dual motion, left and right, and repeatedly. Okay, so I'm going to give the voltage V2. Okay, with a value, okay, 2 kilovolt, while V1 is 0 here. Okay, V2 is 2 kilovolt, example 2 kilovolt. Okay, so you see that between the mover and the center stator, stator B, you see that it's not overlapping, okay, not aligned. So this is where when you apply this voltage 2 kilovolt, the mover will move to the right. So now it's moving to the right. So when we do keep repeating between voltage V1 and then voltage V2, repeat it. So it's going to give you a reciprocating motion. So this is what actuator is about. Okay, giving a signal into the to the system. Okay, so signal is something that we are going to learn in this subject. So what are types of input that you can give to the electrostatic actuator just now? So let's say that we are going to give you a sine wave just now. Then this one is actually the continuous time signal. And the bottom signal is the discrete time signal, which is you are doing some sampling. Okay, what is the sampling? Okay, sampling here you can see that the sampling is roughly 0 to 10. Sampling is 1. Okay, so this is how it's being sampled. And why actually you need to do this sampling in the discrete time? Okay, remember that everything that is being processed by your computer, it can only read in digital. Okay, when digital, then we need to actually convert anything that is from continuous to discrete time. So that is the reason why we have two types of signal, the continuous time signal and discrete time signal. And later on in control, normally you are going to use this discrete time. And even for subject like digital control signal, digital control. If you are taking, I think there's some 4th year here from BEKG taking this subject. So you might be taking subject digital control. Okay, digital control is using the basis of discrete time signal. You need to sample the continuous time with some value. Okay, So let's look, what time 9 already. Okay, can we just take a break for a while, 5-minute break, because I have been babbling just now for 1 hour. So we take 5-minute break. Now it's 9:05 according to my time. So let's take 5-minute break. So we come back again at 9:10. All right, 9:10.
Okay.
All right. Thanks. Hello, testing. All right. Sorry, a bit late. I just went to the loo just now. Okay. So hopefully everybody is back in the session. Right. Can I continue? Right. So let's go to the this slide. So you can see that this one is what I shared in the ULearn under synopsis. So just to trigger you guys, oh, okay, what are we going to learn in this signal system? Okay. So let's see this example. The signal describing the motion and periodic behavior of the Earth climate. So we see that this is an example that is a very good example of what you are going to learn in this subject, which is on signal. Okay, periodic behavior of a signal. Okay, so if you see here is that we have different, we call it signal or we call it wave. Different wave. Okay, the amplitude of the wave is different, and even the frequency is different. So we have different frequency, and we have different amplitude. Okay, here. Okay, so wavelength is 150 feet, means that the height lah. Okay, the amplitude is 450. Wavelength, another wavelength. The dotted the dash line is 500 feet, and another line is 800 feet. Okay, so means that different signal here. Okay, and when combined, okay, this signal will actually give, or this waveform will actually give a very large wave, and this will affect to the boot. Okay, so this is what you are going to learn in the subject. It says is that convolution of signal or combination of signal will actually give a larger signal. Okay, so let's look at example. Okay, I will going to play you a video. Okay. Video. Let me know if you cannot hear the video because I'm wearing the earphone. I'm not sure if you can hear it, but anyway, I will play it and let me know if you cannot hear it. Can you hear the video?
No.
No. Okay, wait. I need to take up.
Can you hear it now? Yes.
Alright. Let's look at it.
まもなく捉えました。大きな津波が2波、3波に確認してできますでしょうか。
This is,
大きな津波が
okay, it's actually large and large. This one is
何波にも分けて迫っております。
back in 2011.
白波を立てて、
So we have a very large
砂浜へ向けて押し寄せているのが確認できます。確認できますでしょうか。1、2、3、3波、4波、それ以上に大きく何度も押し寄せています。
what the media person is saying is that lots of large wave are coming to the surface, to the ground lah, means that towards the shore. Okay, so this is actually live that time. I was let me just explain it. I was there in Japan back in 2011, the Tohoku earthquake. I was in my laboratory, so I'm not sure if I did share to the previous class, last semester class, but let's just me share it again. Sorry if it's repeating. But anyway, I was there back in Japan that time, and I was in Tokyo, and even though it was Tokyo further away from Tohoku was 9 scalar Richter, and in Japan it was 6, so quite large for Japan, for Tokyo, because they have very high-rise building. So this was affected Japan at that time because the Tokyo earthquake was near the Fukushima Daiichi. Daiichi is the nuclear power plant number 1. So what happens is that the nuclear power plant, one of it actually due to the leakage of the some of the nuclear but anyway, it actually affected to Japan in terms of the power supply, the facilities, everything is actually affected that time. Okay, and one thing I remember, I took one month. We didn't have food. 1 month in Japan. 1 week we cannot drink water from the pipe. Yeah, in Japan we can directly drink water from the pipe, but due to the earthquake, because of the leakage from the nuclear power plant, all of the water cannot be consumed from the pipeline. So we actually was rationed for to buy foods or even water. Okay, one person can buy only one bottle, the 1.5 liter bottle in 1 day. So it was very limited, and there's no food in the convenience store, even in shopping mall. So that one is an experience that I cannot forget until now. And even during the time of the earthquake, normally it's normal to have earthquake in Japan. And we have earthquake all the time, but normally it's roughly about 3 scala Richter. Okay, very small one, just a simple goyang and then finish. And just laugh it off. Okay, just say, oh, okay, it's now the G-shape, just earthquake. So, and then we just continue with our life. But that time, the earthquake was, and normally 3 scala Richter is about less than 10 seconds. Very fast one, 10 stop. But that time on 11 March 2011 is that the earthquake was 9 scala Richter and for 3 minutes. So you imagine 3 minutes is like, I'm not sure what I was already praying to God means that I think I'm not going to meet my family. I would die there. Okay, so that is how severe that time, because I can actually see the wall of my building in the lab was shaking. It's like this. Okay, so it's something that I cannot forget, but it's an experience that I don't think I want other people to actually go through. Okay, and this is example of why the tsunami happened, because of multiple waveform. Because when you have earthquake, is that it's going to vibrate. Every time it's vibrate, it's giving different signal. Okay, different frequency, different amplitude. So all of this actually given. If you see here, this is one signal, one sine wave giving up, another signal, okay, waveform, and another coming too. So if you see here, okay, let's just continue with the
こちら撮影機です。津波が南波に向けて押し寄せているのが確認できます。撮影機は現在します。大きな津波が複数波に分けて現在海岸に押し寄せているのが確認できます。
Because you were all scared that time. Right, so okay, this is when the tsunami, I'm not sure if you guys saw this. This was back in 2011. So the tsunami hit the shore and hit all the houses and so on. So you can just imagine, I watched this live on TV, real time, and we know what will happen. Even I do not know if the water will reach me. So that's how scary it was. So you can see this one no sound. So you can see that the wave just crashing down all the houses. Okay. Okay, the water actually reaching the ground, and it's actually collect all the debris on the way. This one is one experience that I'm going to forget. So you see that it's a very disturbing video lah. Okay, I remember I actually stayed and then I went back. Because that time we don't have food and even water, so my parents decided, oh, you need to come back home. Okay, so that time I have 1 day left to finish my PhD. So it's a decision that I need to do. Either you stay here to without water and so on, or you continue. But of course, the PhD is important also. Okay, So because of the water and so on, so I decided that I told my sensei that I need to go back. My parents are really concerned about my situation. So the ticket back is not that cheap, so very expensive. It's 200,000 yen. It's about 6,000 RM. Ringgit Malaysia, one way. Because of that time in Tokyo, there's no ticket back to Malaysia, already full, and I need to go to Osaka by bus and so on. So it was an experience that I will never quite forget. And this actually, if you see here, this is the English.
津波の観測データが入らなくなり、現在津波の高さがわからない状態となっています。このため、東北などでは、これまでに観測された7メートルを超える大津波よりさらに大きな津波が押し寄せている恐れがあるということです。また、北海道と東北の太平洋沿岸の各地で10メートル以上の大津波を観測しているほか、千葉県銚子市と高知県須崎港で2メートル50センチ、横浜港で1メートル60センチ、東京の晴海でも1メートル30センチの津波を観測し、津波は北海道から沖縄県にかけての広い範囲に及んでいます。県内では9人が死亡したということです。また、津波のため出ているところまで津波が来た。路上で男性1人が県内で死亡したほか、トラック、セリ、人が乗った船が津波で流されたという連絡が入ってきたということです。詳しいことは分かっておらず、警察サイト2人で、幕屋町で1人ということです。このほか、
YouTube, there's a lot of video on this tsunami. You can just type there, Tohoku earthquake, Tohoku earthquake, 11 March 2011. So I remember, I actually remember the date because it's something that I won't forget. So that is what happened. So you can see that combination of these three signal. Hello, testing. Okay. Combination of all these three signals will actually come out with a larger waveform. Okay, so this is the idea of the basic signal, signal system here later on. Okay, so let's look at how this signal represented. Okay, so just now you saw that we have three signals, small waveform. So imagine that you have this small waveform, signal 1. You have another signal with different frequency or different amplitude even. So signal 2, and then you have another one, purple line, signal 3, and then another one, 4, 5, 6. So here have what? 1, 2, 3, 4, 5, 6, 7 signal. And this 7 signal, each of these signal, okay, is represented by a harmonic. Harmonic, normally when we, in the time domain, we cannot actually convert it into harmonic. Later on in chapter 3, Fourier series, you will learn how to actually convert this to the harmonic here. Okay, but let me just explain the idea behind it so that you understood more on this topic. So let's say the first signal here is represented by these harmonics, 6 omega, which is frequency, very small amplitude. Second signal, which is represented by this yellow, is by this harmonic, different frequency, 5 omega naught, and with the smaller amplitude, and so on. So you have the the last signal, which is represented by this large waveform. So you have this one with a high amplitude at omega naught. So if you look at this, okay, we call the signal at the 0 point is the DC term. DC is that the amplitude DC, and then you have the fundamental, or we call it as the first harmonic. So first harmonic, second harmonic, third harmonic, 4, 5, 6. So how do you define that? Is when you look at this one, you have the omega naught over here. So if it's 1 omega naught, then it's the first harmonic. 2 omega naught, then it's second harmonic. 3, then 3 third harmonic, and so on. Okay, so combination of all of this signal later on when you learn, okay, we call it as convolution. You will get the convolution of this 7 signal. So you see that when convolve, okay, it will actually give a larger signal. So this is an example that I showed to you of the example of tsunami. So imagine that 7 multiple signal coming towards shore, and then you have a large tsunami. Okay, so that's the idea behind this topic. Okay, so just read one. So I have explained just now on the continuous time and discrete time. So continuous time is defined by xt here. So you write it as xt. Okay. And for the discrete time is you represent it as xn. Okay. So x represent as input and normally y is represent as the output. But of course, sometimes in question, midterm exam or final exam or even assignment, sometimes we can change the input signal as, for example, zt, okay, mt, okay, and so on. So it depends on the question. Okay, so read carefully the question. And for time domain, when we talk about time domain, okay, time domain, we are going to actually use the linear time invariant system. So we are going to use the convolution sum and convolution integral. So this will be covered in chapter 2. Okay, and for the frequency domain later on, which you saw in the example of tsunami just now. Sorry, is this signal just now? Omega naught here. So omega naught is going to cover in chapter 3 and 4. Okay, so we are going to look at the Fourier series, chapter 3, and Fourier transform will be chapter 4. So periodic signal means that a periodic signal, example of periodic signal, what is it? It's a sine wave. It's a periodic signal, means that it's going to repeat, or it can be a cosine wave. Okay, a periodic signal is a signal that is not going to repeat. How do you know that it's a periodic signal? Periodic signal is something when you actually fold it, it will actually overlap or reverse it. So you know that it's periodic when you overlap it. So example, let me just take okay, let's say that we have a signal. Can you see that? A signal like this. What signal is this? Sine wave or cosine wave? What signal? Guys?
Cannot see.
Is it sine wave or cosine wave?
Cosine.
Cosine wave.
Siapa? Syakirin ada bercakap Tak dengar pula. Ada cakap ke? Syakirin?
I cannot see.
Can you hear me?
Yes.
Syakirin bercakap ke?
Yes. Hello?
Hello, Syakirin?
Yeah.
Okay, write in the text, in the chat, What is the signal? Sine wave or cosine wave? Guys, are you there? Hello.
Madam, is it cosine wave?
Cosine wave. Okay, Syakirin, reply cosine wave. Good, very good. I'm not sure, Syakirin, why I cannot hear you. So, can the other student just test your mic? Is it me? Is it me or is it Syakirin? Hello?
Hello,
I can hear you. Okay lah, boleh hear tak apa. Okay, anyway, yes, it's cosine wave. So, just now we were talking about periodic signal kan. So, this cosine wave is periodic signal because why? Example, if I were to actually fold it at the center like this, at the center, here, you fold it, so that signal is going to overlap. So that's what it means. So if it's overlap or reverse it, so there are only two signals that is periodic. Okay, not two signals lah. Other signals can be periodic, but the common one is the sine wave and cosine wave. Okay, so that's one of it. And let's look at how representation of the signal. So I explained just now also. So a signal of continuous time signal and discrete time. So let me just, we have time? Okay, we have 30 more minutes. Okay, I'm going to show this example using MATLAB. Okay, how do you come up with this signal? I'm not sure if you have learned it, but if you haven't learned it, then let's learn it together. Okay, so if you have MATLAB, let's do this exercise. Okay, type in, or if you don't have, then just look at it. So you have the MATLAB exercise. So n equivalent to 0 to 16. So what it means is that, okay, 0 is starting at 0. 60 means that the ending is 60. And you have a sampling of 2, the sampling time. Okay, so next, you are going to plot y. Y is the signal that you're going to plot. So y is equivalent to sine n over 6. So it will plot a sine wave signal. Okay, n means that 60 over 6. So it's going to plot with that frequency. Subplot 211. So what does it mean by subplot 211? Right? So subplot 211 is to plot the graph here. Okay, example, subplot 2. The first number there, 2, means that you're going to have 2 rows. So it's going to plot 2 graphs. Okay? And then second one is the column. So you only have 1 column. So it's going to plot 1 column. Another one is means that it's going to plot on this location. Okay? So subplot, so y sin n over 6 is subplot 211. Plot ny is they ask, is this a command to subplot, plot the yn into this location. So you will have ny, y referring to this signal. So it's going to plot this. Okay, and then you have another one, subplot 212 means that 212 is at the second location. So this one is first location, second location. So it's going to plot stem. Stem means is the command for discrete time. So stem and y. So it's going to plot the same thing what it referred to, which is similar to y just now, just that it's going to plot in discrete time. So this is plot in discrete time, this is plot in continuous time. So you can see that there's a sampling of sampling from 0, okay, to 30, and it's sampling by 2. Okay, so you have 2, 4, 6, and so on, up to 20. Okay, this is example of, so now let's look at, try changing the sampling time. So just let's look at MATLAB. I think I opened MATLAB just now. Okay, this one. Right, so I already opened this in my M file. So if you're not familiar with MATLAB, okay, normally when you open MATLAB, you have this command window. Okay, so what you do is that you go home, new, and new script. Then you have a new M file. Okay, so I already untitled is the new one, but I already typed it out, so I have this M file. So this one is similar to what I have written in this slide. Okay, so same thing. So let's look at this one. So I have, for this case is that I plot n from minus 30 with 1 sampling time and until 30. Okay, let's say that I'm going to evaluate line by line. Okay, with respect to what we have here. So look at this M file and look at the command window, what happened. So I'm going to evaluate line by line. So evaluate line by line is that you can just use the function key. Okay, function key and then F9. So what happens that you see that, oh, okay, it's going to come out n equal to from minus 30 until 30. So you can see that the interval is 1, minus 30, 29, and so on. Okay? So let's look at what happened when I evaluate this line. Okay, just highlight that and then press on function F9. So what happened is that it's going to come up with the signal yn. So it's going to have a plotting, or they already used the equation just now and come up with the signal. So now we are going to subplot it. So when you press subplot, evaluate the line again. Okay, when I evaluate only subplot, it come up with this one. Okay, this is what I mentioned just now. So subplot 2 is going to have 2, 1, 2. Okay, but it's empty now because we didn't run the subplot, second one subplot. So 2, and then you have 1 column, and then it's got to be plot here. But since we didn't run plot yet, so it's empty. So run it next. Function F9. And you see that the graph come out. Okay, according to the signal here. Okay, now we run for another subplot. So you can see that another subplot come out, but without the graph yet because you didn't run the stem yet. Okay, so now run F9. Then lastly, you will get this. Okay, so you see that this is something that it might be useful later on in your assignment. So I'm going to give you an idea how to use MATLAB later on. So the sample just now is asking you, okay, try changing the sample time. So let's see that I change the sample time to 2. Okay, and then since I want to run all, so you want to run all, just click run. Okay. But if you see here, I have percentage evaluate. So percentage evaluate, when you use percentage, it means that it's a node only. So it's not going to run that. So it's going to run what we have here, the black line, black font. The green font is not going to run. So I want to run everything. So just press on run. Okay, change folder. Kejap. Okay, you can see that what happened just now. You see that this graph, it changed. Sideways is for the continuous time is still the same. Okay, but for the discrete time, it actually changed the sampling. Okay, so let's just look at it. Okay, change it back into sampling time 1, run it. You can see it plot with a smaller sampling time. Let's say I want to plot it 0.5. 0.5. Run it. Then you have more sampling. So if I were to use a larger sampling time 5, you see what happened to the signal? Okay, the signal actually become distorted because of the deformation is missing. So that's why the smaller the sampling time is much more better. Okay, I'm using 0.1 here. Okay, you have more accurate signal here. Okay, so that's the idea behind continuous time and discrete time signal. Okay, I'm going to close that. You continue with the slide. Okay, so try to do this at home later on. You open your MATLAB and do this exercise. Okay, next we go to, I hope we can finish a few things here. Okay, next we go to the time transformation. Okay, so we have transformation of independent variables. We have normally 2 types, time transformation and amplitude transformation. Okay, but I'm going to focus more on the time transformation because when you get the idea of time transformation, you will normally get the idea of amplitude transformation. So for time transformation, there are 3 types of transformation. The first one is time shifting. Second one is time reversal. And third one is time scaling. So let me explain one by one. What is the meaning of time shifting? So time shifting is done. Okay. In this topic, I'm going to explain both continuous time and discrete time together. So when you see that it's in a bracket, means that is continuous time. When you see that it is in a square bracket, it's a discrete time. So we have the signal. Okay, t. T in discrete time. So normally, okay, we look at this signal. Okay, xt is the normal signal. It's given by this. Okay, so xt here is given by this. Okay, we have a signal like this. It's not a periodic signal. It's just a random signal. Okay, so when you have time shifting, is that the time shifting? What happens is that you will actually transform it become x t minus t naught. So we have x t just now minus t naught. So if you see the definition of delay at advance here, okay, for delay is the t naught, okay, and the t naught is more than 0. Means that what? If t naught is more than 0, it's positive, right? So if it's positive, for example, t naught is 1. So you have x t minus, because it's positive 1, minus 1 lah. Okay, so x t minus 1. So this is example of delay, time delay. Example, we take an example of advanced signal. So we have t naught on n naught is less than 0. So t naught is less than 0. It's example of x t less than 0 means that minus, right? So you have t naught, for example, minus 1. Okay, so when you fill into this equation, you have xt minus 1, right? Minus 1 is plus 1. So this one will represent an advanced signal. Okay, So the difference between advance and delay is by the sign there. Okay, sign. Where's my, where's the, okay, sign here. So we have minus for the delay and positive for advance. So let's see this example signal here. We have the original signal xt over here. Okay, and then you transform it, you have xt plus t naught. Okay, t naught is not given by any value. So imagine that is xt plus t naught. So you know that, oh, there's a plus sign over here, kan? So it means that when you have a plus sign, it's a time advance. So time advance means that if you see this signal, what happens that the original signal is at this position. Okay. If it's time advance, that is actually what happened is that this signal is being shifted forward. Okay. This signal is being shifted forward. You can see how it's being shifted. You take this point here. Okay. This point, higher point, it's actually being shifted to the left side of this axis. This is 0 axis. This is 0 axis. It's being shifted to the left side. This is positive and it's being shifted to the negative side. So it shifted to your left side. Okay. It's similar to what you see in oscilloscope. Oscilloscope is moving from right to left hand. So that one is time advance. Okay. So very simple. This is example of time advance. So let's look at this example. Okay. We have this signal. Okay. xt. Okay. And then we have x and minus n naught. So what is this signal represent? Is it time delay or time advance? Guys, delay or advance? Can you answer using your mic? I want to be have a quick answer from you guys. Is it time delay or advance? For the left,
Time delay.
Raf?
I think
I
Dr.
cannot.
hear it. I
I'm
think
not
Dr.
sure
can
why.
hear us.
Why cannot this? I cannot hear you guys. Sorry, Hey, try speaking again.
Hello,
Guys?
sir.
Time delay, Doctor.
Can you hear me? I don't think Dr. can hear us.
Time delay,
I
Doctor.
cannot.
Can you hear me?
No, they can't hear
I
us.
check my setting.
Hello?
Hello, Dayat.
It was okay.
Hello, guys.
Setting. Testing.
Testing. Hi, Doctor.
Ya, Doctor? Ya, Doctor?
Okay, boleh dengar. Sekarang dah boleh.
Okay.
So Dayat said it is a time delay, Doctor.
Okay, can you answer that?
Time delay.
Okay, wait. Sorry. I don't know what happened just now. Should be okay. So this one is time delay. Time delay, Okay,
Yeah.
why? Because when you look at this, you have the original signal, so you have x and minus n naught. So I just mentioned just now, very easy. What you need to do is that you need to look at the sign, So the symbol. So you have negative, so delay. So just remember, everything that is delayed is going to shift to the right side. Okay, delay. Something like when we example, when you have a sensor, you're using sensor, sonar sensor underwater. What happens that the signal, the sensor will actually give a sine wave, give out the sine wave, and it was going to reflect to some material and it's going to come back. So when it come back to the sensor, to the receiver, it's going to have it delayed by how many minutes or period or second. Okay, so that's why when the receiver receive the signal is going to be delayed. So that's why that's how it calculate the distance between the object. So this is time delay. Okay, correct. So this is example is delayed by 8. Okay, so it's being shifted. This is, we take it, this is original. It's going to be shifted by 8 here. And then the second one is time advance lah. Okay, I just showed you the answer again. So anyway, it's going to be time advance. Why? Because it's being shifted to the left. So this one is t plus 5. Okay, so this one is, sorry, plus Okay, let's look at example here. I think you can just do it at home. Very simple. Find xn and xt. Find. Okay, so these two example is I directly give you example of this is discrete time because you have the sampling, and this is continuous time. Okay, so the difference is that the bracket. So given this signal, find xn. So xn plus 10. So this one is advanced signal. So you know that it's going to move to the left. Okay. So let's say that I'm going to draw it that. I'm going to shift it. For example, this is -5. So to the left side is going to be -15, right? So everything is going to be shifted to the left side. Okay. So you don't draw like me. You need to draw it in discrete time. Okay. Draw it in discrete time. Something like this. And then for the right side is that you have the original signal xt. So write using the equation xt minus 20. So draw the signal. So when you see minus, then you know that it's going to be shifted to the right side. So means that everything you have here is 0. So let's say that it's going to shift 20. So it's going to be 20 here. So everything is going, let me just eyeball that, shifted to the right side. Okay. So next, let's go to look at time reversal. Okay, time reversal. We have here signal reflected at TON. So this is very simple, time reversal, reflective signal. Okay, the one that I asked, the one example of tape recorder. When you reverse it, what happened? It will reverse everything on the tape recorder, right? So what we have is the original signal xt, and when we see minus in front of the t, then it's actually time reversal. Or minus in front of the n, then it's time reversal. Okay, so some example is xt here, original signal. So what you did do is you're going to flip the signal in the time axis here, flip it. Okay, so when you flip it, you will get the reverse of this signal. Okay, so that is how simple time reversal means. So flip that. And for time reversal, this one example, just you can just look at it. So you have xn, so when you reverse it, you will get this signal. Okay, and for continuous time, when you have this xt, you reverse it, you get this opposite signal. So you flip it. Okay, next one is time scaling. So time scaling is when you have original signal xt, and when you do time scaling, you know that it's time scaling when you have x and you have a value in front. So alpha t, example, alpha is a value. It can be 2, 3, 4, and so on. Okay. So for the discrete time, we have x, alpha, n. So every time you see there's an alpha there, or value, then it's a scaling factor. So what does it mean by that? So if you see that the scaling factor is less than 1, so less than 1 means that 0.5. So the signal is stretched, means that it's become larger. And for the signal is more than 1, for example 2, signal is become compressed. So you don't need to memorize this. I give you a concept of tape recorder. So tape recorder or video, even video, YouTube, and you normally run the video. I would like to run it 2 times speed. Okay, what does it mean by 2 times speed? Means that you're going to play the video twice speed, faster. Kan? If the video was 30 minutes, you play it 2 times. So it means that it's going to be 15 minutes. Okay, so this is what it means. So this scaling factor 2 means that that's why the signal is going to be compressed. Shorten 30 minutes, shorten to 50 minutes, half the time. Okay, and when you have 0.5 means that you have a signal, you have a period of 15, for example, 15 minutes is going to be stretched out to 30 minutes. So this is what it means. So referring to the signal xt, okay, so if I were to have this one, x 2/3t, so it means that what? The alpha is 2/3, right? Okay, so that's how you extract the alpha value. Okay, so 2/3, is it less than 1 or more than 1? Guys, less than 1 or more than 1? Less than 1, right? Less than 1. So it means that what? is going to be stretched. So that's why you see here the signal is stretched out. Okay, stretch out. Okay, so it's a very simple one. Okay, you have this signal xt. So let's say you want to draw this in a compressed mode. So x 2t, scaling factor 2, which is compress or stretch. Compress or stretch. Compress, eh? Okay,
Yeah.
so you're going to make it compressed. And for the below is t over 2, means that alpha is 1 over 2, less than 1. So that means that is going to be stretched out. Okay, so that's the concept lah. Okay, I think I cannot go further on this topic because when the next topic will be on exercises on using the combination of all these three types of time transformation, and we are going to use the time shifting, the time reversal, and time scaling. So, and there are two methods how to do this exercise, but we don't have time right now. So I will stop here for today. Okay, before we exit today class. Okay, can you guys, okay, in the Padlet, in the Padlet, right, I think I have the equation just now. Actually, I planned a lot for today, but basically, we don't have time. Okay, so, okay, in the Padlet, okay, go to column number 2 here. Based on today's class, which part don't you understand? Okay, so go to Padlet. Padlet is the same Padlet just now. Okay, just click on it. Okay, you can tap your name if you want. If you don't want, it's okay. Just type out the what you don't understand so that I can just further explain it next week in the beginning of the class. So type that out. Okay, and remember we have the last reflection here. Go to the class reflection lesson 1.5. Sorry, I'm not sharing my screen. Okay, not sharing my screen. Okay, sorry about that. Okay, go to Padlet. I thought I was sharing my screen. Okay, go to Padlet. Okay, there's a in the Padlet, in the second column over here, I already put out based on today's class, which part don't you understand? Okay, which part? Is it time transformation? Is it time scaling? Is it time reversal? Okay, so if you understood, just answer there. I understood all. Okay, if no, then just type there. No problem, no worries. Don't be shy. Just share there. If you don't, then we will discuss it next week. At the beginning of next week. And then before we go out, we finish out our class. Okay, just go to YouLearn. Make sure those who just came, you enter late, just join please go to the group selection. Make sure that you select your group already. Means according to your section. And then manually tick the attendance for lesson 1.1. Okay, don't forget that. This is actually to collect the attendance for the ISO. Okay, and then, and then we are already at the last lesson 1.4, which is class reflection. So each student is compulsory to fill in the feedback form. This is consider attendance. Even though you click there at the beginning that you attended, but I do not know if you are staying with me right now up until the end of the class. So you need to fill that up. It's very simple. Okay, I will just open that to show to you. Okay, cannot show to you because I'm the instructor. But anyway, the question will be something like this. Okay, describe what we have learned in class week 1. So right there, what you have learned, you can write in a paragraph. It's up to you. It's okay. Then, do you prefer synchronized, or combination? So you just tick that, and then just elaborate why you think that you agree if the synchronized class, asynchronous is good also. Okay, so that will be all. Okay, so there are two things. The feedback form here, make sure that you complete it by today. Right now, do it now. Okay, just a few minutes to complete it. Then I think that would be all. Any question?
Sorry, Doctor, do we need to do the exercise one?
Exercise one. No. Exercise one, no, because
We
actually
haven't
I
done the
didn't reach
method
that.
two.
Yeah,
Right.
I haven't
Okay,
teach you method one and
Method.
two, so don't do that.
Yeah.
Exercise one, no need. This one we will
Oh.
discuss next week, okay? Because I haven't teach you guys yet. Okay.
Okay,
So just do the first and second column only, how to plot. Oh, okay, how to plot graph using MATLAB. Okay. And by the way, this for today class I recorded it. Okay, so I'm going to share to you the what's my YouTube? I'm going to this is my YouTube. My YouTube. Okay, this is my YouTube channel. Okay, actually, if you go through my YouTube channel, I have done classes on signal system before. So, but for chapter 1 and 2, it's not there in my YouTube. So, later on, the class recording will be uploaded here in YouTube, and I will inform you via Ulearn or also via Telegram. And so you can just go through again. For those who, in the Padlet, I will see which one that I can answer that you can actually refer to in the YouTube video, the recording, and the one that if you need me to explain again on the time transformation again, I will just explain it next week, because we are going to actually use it next week also in the method 1 and 2. Okay, so I think that's all from me. Any more question? Time delay. Oh, okay, that's answer. So any more question? If no question, that would be all. Thank you, guys. So see you next week on Wednesday, 8 a.m. sharp. Alright, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Bye.
Waalaikumsalam.
Thank you,
so much,
madam.
Doctor.
Doctor, thank you, Doctor.
Okay, welcome. See you guys. Go and take a breakfast.
Sure.
Okay, thanks.